Okay, let me start. Can you guys hear me? Can you guys see my screen as well? I started sharing the screen. Okay, all right. Where is the PowerPoint thing? Okay, here it is. And we have seen all these problems, right, last week. Mhm. So that's fine. So what we will do is today we will discuss more about one more week is left, so we will have some sufficient time. This week we'll discuss about counters and whatever is relevant to that. It's like analysis thing. Next week we will go for the static timing analysis and all those things. Okay. Hmm? For a flip-flop and then setup time, hold time. What is the concept? It's very new, very easy, not that very tough. So, oh, all right. So let's discuss about counters. Hmm. All of you know about T flip-flop, right? So this is T flip-flop. Let's say there is a clock, hmm, Q bar, and if we talk about characteristic table, if T is 0, same state will be repeated, no toggling. Hmm. If T is 1, okay, toggling, right? Toggling will take place, right? That's why it is also called as a toggle flip-flops, okay? So this, keeping this in mind, and also we know what is this? This is clock, right? Positive edge triggering or positive edge sensitive clock. Okay, whenever you apply 0 to 1 transition, okay, then this flip-flop will be sensitive towards that particular clock input, and then whatever, depending on whatever the input that T is receiving, it will perform that particular particular, it will show the particular output depending on toggling or not toggling. Keeping that in mind, let's look at this counter. Hmm. Pay utmost attention that is possible, and right. So because these basics we know already, so pay utmost attention to the first concept that I am going to discuss. Then you can start you can start solving problems on your own. Not much uh, big deal about that. To do that, what I will do is I will take a 3-bit counter, okay, and this counter, okay. Am I guys still audible? Can you guys hear me? Can you see my screen? Okay, great. So what I'll do is I'll take T flip-flops. T, T. Let's say T1, T2, T3. First 10 minutes, don't ask me why am I doing this. Later I'll explain. I'm keeping the counters in the toggling mode because I want the output to change 0 and 1. I don't want the output to be there at 0 all the time, right? Only way I can do is keeping it in a toggling mode. I am just keeping that in the toggling mode. Uh, and you have Q3, Q2, Q1, right? And I'm not concerned about Q3 bar and all those things, okay? Now what happens is, this is which triggering is this? Negative edge or positive edge? Which sensitivity is? Can anybody answer? Is it positive edge triggered flip-flop or negative edge triggered flip-flop? Very good. Negative edge triggered, right? Then what I'm doing is I'm connecting Q1 as a clock to the next flip-flop, right? Flip-flop 2, and Q2 as a clock to next flip. And this clock will have a lot of edges. Negative edges or positive. I'm concerned about the negative edges, right? Okay, this is not a negative edge. This is a negative edge, right? Like this. Okay, let me analyze this. I'm also assuming that the initial states are 0, 0, 0. Okay, so clock, hmm, I applied nothing. I'm writing Q3, Q2, Q1 in this particular way. And people may ask me, sir, why Q3, Q2, Q1? Why not Q1, Q2, Q3? It's okay. Just leave it to me. I told you, first 5-10 minutes, just leave it to me. Leave the floor to me. And let me, put the things in perspective. Then we can discuss about that. When nothing is applied, I know we are initializing the states 0, 0, 0. Now, this clock has this is a waveform of the clock, right? Right. Does this have a negative edge? This is a negative edge. This is a negative edge. This is a negative edge. Right? This is a negative edge. This is a negative edge. One negative edge to another negative edge is nothing but clock time. Hmm? And what is the frequency of the clock? 1 over the T clock, right? Hmm? Right. So, first thing is, if you apply the clock, right, that means that first negative edge has arrived at this point. And is the flip-flop sensitive to negative edge? Yes. Now, which mode is this in? Toggling mode, because this is 1, right? So output will be toggled like 0 to 1, right? Q1 will become 1. Now tell me whether Q2 change or no. Does this transition affect the Q2? Q2 is 0. Can anybody answer? No, right? Because 0 to 1 is a positive edge, right? And it is negative edge sensitive. So obviously there is no change. 0 to 0, not an edge at all. So this also becomes 0. So Q2 is 0, Q3 is 0. Guys, is this point clear? Let me know through your chat box. Are you guys clear about that point? Yes or no? The first transaction. Yes. Even a mildest doubt should not be there. Yeah. So what I'm trying to say is, okay, let me erase this bit. So this is how a clock waveform will look like. These flip-flops are in toggling mode. The initial contents are 0, 0, 0. So now, because of the first clock has come, first clock means first negative edge has come. This T flip-flop is already in toggling mode. Then the output will toggle, right? So Q1 will become 1, right? Now 0 to 1 is happening here, right? See, 0 to 1 means what? This Q1 is changing from 0 to 1. This you are applying as a clock here, correct? But this flip-flop, the second flip-flop is negative edge sensitive. 0 to 1, is it a negative edge or a positive edge? 0 to 1 is a positive edge, correct? So what will happen here is, this flip-flop is not sensitive to that. So that will not be activated at all. What will happen? Because of that, 0 will remain 0. Now 0 to 0, no edge only, it's a level, correct? So this will also become 0. So Q2 will be 0, Q3 will also be 0. Okay, is this point clear, Ravali? Okay, all right. That's it. Nothing else is there to discuss about this. Very simple topic. Now, second negative edge comes, right? First one is over, second one comes. This flip-flop will be always activated. So output will be toggled. Now 1 to 0 is there. Now 1 to 0 is a negative edge, correct? 1 to 0 is a negative edge. That you are applying as a clock to this. So obviously this will also be activated. Right? What will happen? Output will toggle. Why output will toggle? Because you kept this is in toggling mode. All the t inputs are at 1. Now 0 to 1 is a positive edge, so this will not be activated. So this will become 0. Right? So Q1 is 0, Q2 is 1, Q3 is 0. Is this point clear, guys? No change. Just we are first we are understanding whether negative edge or positive edge is there or not. Then based on that we are toggling it if at all if it is there. Otherwise we are leaving it as it is. Right? 2 iterations are done. Now let's say third negative edge comes. What will happen? This will be anyways activated because clock is directly applied here, 0 to 1. Correct? Now 0 to 1 is a positive edge, and that we are applying as a clock to next flip-flop. So it will not be activated. So 1 will remain 1. 1 to 1 is not an edge at all. So this will not be activated. This will remain as 0. So your Q1 is 1, Q2 is 1, Q3 will be 0. Right? Please interrupt me if at all something is not clear. Next, when the fourth clock comes, third edge, fourth edge comes, correct? Then what happens? This will be activated. Then output will toggle, and this we are applying as a clock to this. 1 to 0 is a negative edge, so this will also be activated, and this is in toggling mode. This will be 0. Again 1 to 0. 1 to 0 is a clock that you are applying here, correct? So it will be activated and the output will toggle, correct? So Q3 is 1, Q2 is 0, Q1 is 0. Like that, if you continue, similar story will happen. 1 0 1, then 1 1 0, 1 1 1. You will end up at 1 1 1. Okay, so you will get 1 here, 1 here, 1 here. When you apply the 8th negative edge, what will happen is this will be activated 1 to 0. 1 to 0 is negative edge, this will be activated. You will get 1 to 0. 1 to 0 is a negative edge, this will be activated 1 to 0. Obviously, you will go back to the 0 0 0. So you have come back to the initial state that you started. Right? Go back to the initial state and repeat the same story. Right? Now let me tell you why I taken Q1 as LSB. See here, I can consider Q1 as LSB, Q3 as MSB. Correct? So before we go to this, hey, are you guys clear about this? Such a simple technique, such a simple concept. That's it. Nothing else is there in counters. This is, if you know this much, that's fine. Okay. Actually, there is some signal fluctuations at IISc. So I think, let me know, okay, if something goes wrong or something like that. Now, you look at, let's say I'll take 3-bit binary, for example, 0 0 0 0 0 1 0 1 0 0 1 1 0 1 double 0 1 0 1 1 1 0 1 1 1. If I ask you what is changing frequently, then you will say LSB, right? It keeps changing it. MSB changes the least when compared to all other things, right? Now you look at this circuit, because clock is directly connected to this particular flip-flop, 1, and that particular node tend to change rapidly. See 0, 1, 1, 0, 0, 1, 1, 0, all the way compared to Q3. That's why I have taken Q1 as LSB, Q3 as MSB. Consider it. Right. That point is clear, right? Now, if I consider Q1 as LSB, okay, Q3 as MSB, if you look at this, if you look at the decimal equivalent, this is 0, this is 1, 2, 3, 4, 5, 6, 7. Now, if you look at this sequence of numbers, can I say this as a up counter? Yes, we can say that as a up counter. Correct. So this will act as an up counter. This could be one of the gate questions. And also, you look at in terms of timing. Okay, in terms of time, let's say I consider every flip-flop take a processing time of TD to process the output. Okay. See, at the end of the day, it's all the elements that are responsible for processing, right? Internally. So generally, Q1 takes TD time, Q2 takes 2 times TD, Q3 takes 3 times TD. Yes or no? To show the stable output. That means that these are not synchronous. They will not change at the same time. Even though I designed a ideal flip-flop with the ideal time delay of TD, TD, TD each, but the outputs change differently with respect to the clock. Once you apply the clock, one flip-flop will take TD, another flip-flop with 2 TD, another flip-flop with 3 TD. They are asynchronously related to the clock. Okay, that is why it is also called as asynchronous up counter. Okay, right? Also, this is also called as, see, when you apply the clock, this is going to affect the Q1, that is going to affect the Q2, that is going to affect the Q3, right? That is why it is also called as a ripple counter, right? When they say ripple up counter, that means that they are talking about asynchronous counter, right? When they say binary up counter or binary synchronous counter, asynchronous counter, I have to mention clearly. Okay, if they say ripple up counter, then obviously that's a asynchronous counter. Is this point clear, guys? Can all of you tell me yes or no through your chat box? Okay. What about remaining people? I can see only 3 people responding. Remaining people, are you guys alive? Are you guys there? Okay. I can do one thing in my own way. I can ask individually. Okay. Sadat, are you clear about this? Okay, all right. Thank you. Amruta, are you clear about this? Type in your chat box. Then, all right. Fine. This is called litmus test. Okay, right? This is the naming. This is like a naming ceremony, right? Depending on the functionality, we are naming this counter as that or this, right? Now, the other aspect, many questions will come based on the timing. For that, let's talk about clock. Let's do this analysis, right? You have a clock. Oh, sorry. I need to draw it a bit quicker. Hmm? Identify the negative edges because that is what is important, right? First negative edge, second, third, fourth, fifth, sixth, seventh, eighth, ninth, 10, 11, 12, 13, 14, whatever is required, right? Now, Q1, before applying the clock, Q2, Q3. Correct. Let's understand Q1 how it changes with respect to the clock. Right. Q1 is what? Is a LSB, right? You look at this. Q1 is sensitive to clock. Q1 is sensitive to negative edges on clock. So Q1 is negative sensitive to negative edges of the clock. So till there is a negative edge, initial value is 0, right? This is 0. Once there is a negative edge, this is in toggling mode. So output rises to 1. Then it will continue until it see one more negative edge became 1. Again negative edge means again it will come back to 0. Continue. 1 toggle. Wherever there is a negative edge, there is a toggle. This is called timing diagram. Right? This is about Q1. Okay, 0, 1, 0, 1 and all those things. Okay, no need to worry about that. Now what is Q2 is sensitive to? Q2, you see this? Q2 we already discussed. Q2 is sensitive to negative edges on Q1. Right? Q2 is sensitive to negative edges on Q1. Okay. So let me take another color which is okay. Right. Till this point 0. Now Q2 is sensitive to negative edges, right? Find out where is the negative edges in the Q1. Here is one negative edge, one negative edge, negative edge, negative edge, negative edge, negative edge. Like negative edge is nothing but 1 to 0 transition, right? 1 to 0. Wherever 1 to 0 is happening, that's a negative edge, right? 1 to 0, 1 to 0. Q2 is sensitive to negative edge, right? So let me mark up wherever, right? So at this point, till Q2 will be 0, then it will rise to 1 because it sees a negative edge, then it will go, then again it will come back to 0, then again come back to 1, 0, 1, 0, something, 1, 0, 0, 1, 0, right? Now, what is Q3? Q3 is sensitive to negative edges on Q2. This we know by now. There is negative edge here, there is a negative edge here, there is a negative edge here, right? How it will be? Initially 0, all are 0, 0, 0. Then it will continue till this point as 0. Then it will become 1. Then become 0. Then again becomes 0. Then again becomes 1, like this. Correct. This is 1, 0, 1. Correct? Next question is, what is the frequency of each thing? Clock frequency, see, I can easily calculate, I can assume that, let's say this is the clock time period, right? Between one negative edge and another negative edge, right? We all know T clock is a clock time period. Then F clock is 1 over T clock, right? This much we know. Now you see, this is, let's say, one negative edge to another negative edge. I say this is TQ1, correct? I can relate TQ1 to clock time period as 2 times T clock. Clear, right? This is one T clock, this is another T clock, like 2 times T clock. What about TQ2? TQ2 is, right? You tell me, this is 1 times TQ1, this is 2 times TQ1. I mean, completely, like 2 times TQ1. That is equal to 2 into 2 times T clock. That is nothing but 4 times T clock. TQ3 is, obviously, if we compute, 8 times T clock. So we know what is FQ1? 1 over TQ1. That is nothing but 1 over 2 times T clock. 1 over T clock is F clock. This is F clock by 2. Similarly, FQ2 is 1 over TQ2. 1 over 4 times T clock. This is F clock by 4. FQ3 is nothing but simple F clock by 8. Okay. Are you guys clear with this? Let me know. Yes or no? Yes. Am I making up counters thing simple or am I making it complicated? If you think I'm making it simple, you can type simple in the chat box. Simple. I'll make even more simple the static timing analysis. Now, so based on this, what I can tell is, let's say you have a 3-bit counter, same configuration, no change. Okay, Q1, T2, Q2, T3, Q3, connected in toggling mode. This is connected as a clock to another flip-flop. There is a clock, let's say. Now, what I can derive is, suppose if I'm operating this in the, it will obviously act as an up counter. Let's say it is acting as up counter. If the frequency of the clock is F, this guy's frequency is F by 2, this guy's frequency is F by 4, this guy's frequency is F by 8. I can use it as a frequency divider network. So this will be extremely helpful when I have an IC integrated chip. Some block needs frequency F, some other block needs F by 2, some other block needs F by 4, some other block needs F by 8. I can use this to generate, I can use this counter configuration to generate a frequency divider network, okay, whichever the way I want. So I have a stable source F. Okay, I'll just connect it. See, this is simple actually. I can connect this to a crystal oscillator. Okay, I will take these outputs and then connect to the circuits wherever whatever need these particular frequencies. So using a single frequency, we can generate multiple frequencies of different number. Is this clear? So if you want to generalize it, okay, this is f by 2, this is f by 2 power 2, this is f by 2 power 3. Suppose if I have n bit counter, see it is a 3-bit counter, right? 3-bit up counter. You have f as the input side, clock frequency. You have f by 2 power 1, f by 2 power 2, f by 2 power 3. If you have n bit, then f by 2 power 1. You have f source, then f by 2 power 2, f by 2 power 3, and so on. What is the final frequency? F by 2 power n. For 3-bit, you see, for 3-bit you got f by 2 power 3. For n bit, you will get by 2 power n. These many frequencies you can have along the line. Okay. So also there is something called as, let's say you have something called as, you might have heard already, mod 8 counter, mod 7 counter, mod 6 counter. For this, what you are supposed to do is, you see how many stable states are there. In this counter, how many stable states are there? 1, 2, 3, 4, 5, 6, 7, 8. So I can say this as a mod 8 counter. See, I can say the same thing as, see, different names, okay? Up counter, ripple counter, asynchronous counter, mod 8 counter, correct? We can use like this, ripple up counter, ripple mod 8 counter, asynchronous mod 8 counter, asynchronous up counter, right? Many ways, right? But you need to know the terminology, that's all, nothing else, right? So once you are done with this, there are typical problem, like let's say for example, in this case, is there any limit on the frequency, or can I apply whatever I want, is the question. So that will be very much simple. See, once you apply a clock edge, let's say you applied a negative edge, right? You have to wait till the last bit or the last MSB till till the output of Q3 gets stabilized, right? So in the 3-bit case, 3-bit counter case, if every flip-flop has a delay of time delay, processing delay of TD, you have to wait at least 3 times TD before applying a negative edge. Okay, you applied first negative edge. Before applying the next second negative edge, at least 3 times TD you have to wait. Correct? So this could be the clock frequency. So your clock time period. Your clock time period should be greater than or equal to 3 times TD. Anything greater than is fine, but it cannot be less than 3 times, because you are not allowing the you know the time for the flip-flop to generate a stable output. Are you getting it? Since T clock must be greater than or equal to 3 times TD, 1 over T clock, if I do divide by, right? Yes, Ashutosh. Sorry, Avinash. Yeah, add everything, no? TD1 plus TD2 plus TD3. You have to allow that much of time, correct? So generally, from the gate perspective, they may not give you this kind of typical problem, but they say every flip-flop has a time delay of that. But anyway, that's a good question. You just sum everything TD1 plus TD2 plus TD3. That's all, right? So, and you know these basics, right? If 10 is greater than 1, obviously 1 over 10 is less than 1 over 1, right? Correct? So 1 over T clock will be less than or equal to 1 over 3 times TD. So your F clock is, okay, where is it? Mm-hmm. Hey, if you have any questions, no need to raise your hand now. You just unmute yourself and then interrupt me, okay? Luckily, I was attentive and then I listened that sound. So 1 over T clock is F clock should be less than or equal to 1 over 3 times TD, means F clock maximum frequency, that is nothing but 1 over 3 times TD. This is the maximum that you can do. So this is for an 3-bit flip-flop, right? 3-bit counter. So for an n-bit counter, no need to tell you, your F clock maximum is 1 over n times TD. That's all from my side on counters, guys. Any questions, please shoot out. If you know this basic, you will definitely get 2 marks. Just believe me. Because whatever that comes up later on is all a manifestation of the same concept that we discussed. Either they may ask you in terms of after 3 clock cycles, what is the output, or after what is the frequency of Q1, what is the frequency of Q2, if the input frequency is given, whether it is up counter or a down counter or asynchronous up counter, asynchronous, all the same story. But if you know this is the basic level of understanding, then you can able to answer anything. Are you guys clear? Say yes or no. Okay, great. Okay, so what I'm saying is, in order to make it, in order to, okay, I'll draw this and explain again. You have a flip-flop, right? 3 flip-flops you have, T1, T2, T3, they are in toggling mode. The output is connected as a clock, Q1, Q2, Q3. Now, there is a clock here. Now, this clock is having some frequency, right? Negative edge to negative edge, this is nothing but a T clock time period. F clock will be 1 over T clock. Now, the question is, can I apply any frequency, or is there any limit on the frequency? Can I apply infinite frequency? Obviously, answer is no. Why? Because once you apply the clock, let's say you applied this clock, you want the Q1 to get stabilized, Q2 gets stabilized, Q3 gets stabilized. When the Q3 gets stabilized, only when Q1, Q2 gets stabilized, and then processing time should be given to third flip-flop. Let's say this is TD, TD, TD. Q1 gets stabilized after TD, I mean just TD. Q2 gets stabilized after 2 times TD. Why? Because it has to wait for the data to be processed by Q1, then processed by this. Q3 gets stabilized after 3 times TD. Now, if you give enough time, then only you can apply the second clock. So, minimum time you need to wait is greater than or equal to 3 times TD. Let's say TD is 1 second, for example. You need to wait at least 3 seconds for the Q3 to show the stable output, right? So, anything more than 3 seconds is like, okay, fine. You can take clock time as 4 seconds, 10 seconds, 100 seconds is fine. But you cannot apply a second pulse at 2 seconds because still the processing is going on. When the process gets over after 3 seconds, right? Now, same discussion I am making in terms of frequency. What is frequency? 1 over T clock. that should be less than or equal to 1 over 3 times TD, correct? See the inequality change, mathematics, right? F clock should be less than or equal to 1 over 3 times TD. So the maximum frequency that you can use is 1 over 3 times TD, not beyond that. See the limit. You can have a maximum limit on this as 1 over 3 times TD. Now, one of the other student was asking is, what if the the I mean processing times are different, TD1 plus TD2 plus TD3. We can also say time delays. Then what you should do, instead of why 3TD came here is because I wrote TD plus TD plus TD, correct? Instead of that, you write TD1 plus TD2 plus TD3. No problem. Instead of this 3TD, you will get TD1 plus TD2 plus TD3. Like you can say sigma of TDI, where I ranging from 1 to n, whatever it is. Sadat, is it clear? Yeah, you can say, processing delay, delay, something like that. Okay. Yeah, you can visualize like that as of now. Right? So these are the up counter discussion. Similarly, one can do down counter discussion. So what happens is this, right? You have, we already know this, right? Already we have studied. I'm repeating again. T1, right? Q1 as a clock, Q2, Q3, correct? And there is a negative edge. Now this is acting as up counter, right? To make it as up counter, what did we do? Negative edge triggering plus Q as a clock, right? We applied Q as a clock to the next flip-flop. Now tell me one thing, just based on intuition. Suppose if I apply Q1 bar as a clock instead of this, what will happen? Whether it will still act as up counter or down counter. And I'm considering my the outputs at here only, X, Y, Z. That is not, there is no change in that. Instead of Q1, now I apply Q1 bar as a clock. What will happen to this counter? There is no change. Only clock has changed. That's all. Yeah. Can you guys analyze and then tell me? I'll just wait for 2-3 minutes. You do the same analysis, 0, 0, 0. And your focusing points is also Q3, Q2, Q1. There is no change in the focusing points also. Okay. Q3, Q2, Q1, where Q1 is LSP, Q3 is MSP. Nothing is applied. Q3, Q2, Q1 is 0. Only one change that I did is, instead of applying Q1 as a clock, I applied Q1 bar as a clock. Still, I am observing the output at Q1, Q2, I mean Q3, Q2, Q1. No change in that. Let me have some water. Hey guys, I'm having water, so I removed my headphones. Yes, I'm back now. Let me know your answers through chat box. Does it act as up counter or down counter, or it doesn't work at all? Okay, Sadat is saying it will work as a down counter. Ravali is also saying it's down counter. Yes. So I'm not going to discuss that. Answer is down counter, obviously. Okay. So if you look at that, then it will act as a down counter. See, you haven't changed anything. Only thing that is changed is feed forward path is changed. Instead of connecting Q as a clock, you just connected Q bar as a clock. Then it acts as a down counter, right? So negative edge triggering flip flop plus Q as a clock, it will act as a up counter, right? This is what we have understood. Then negative edge, obviously, if the Q bar has feed forward clock, then it will act as a down counter. Now there's ulta way here. Instead of negative edge, if you took positive edge triggering plus Q as a clock, any guesses? Obviously down counter. Are you getting it? Then positive edge triggering, Q bar as clock, obviously it is a up count. So these are the four different configurations that you can work around to get different counters. Right? There are a hell lot of problems on this. So okay. So we can discuss about that. Hmm? So next point is let's say okay, let's solve some problems on that. Okay. So this is JK flip flop, JK flip flop, clock, clock. Hmm? J is 1, K is 1, right? So what is XY after 3 clock pulses are applied? Okay, initial states is 0, 0. What is XY after 3 clock pulses are applied? If there is any confusion in the clock and all, I just rewrite this. Initial state of the counter is 0, 0. So what is XY after 3 clock pulses are applied? Option C. Okay. One answer we got is one option C. Okay, one more answer, and that is also option C. Okay, this is a two more question. Okay. Okay, let's see. These are looking at that positive. No, no, minus 2 by 3. That's all. Okay, anyways, I'm just kidding. So positive edge triggered flip-flops, right? So you have a clock, and there is X, there is Y. That's what they are asking, right? X and Y. Nothing is applied. The initial states are 0 and 0. Now, when you apply the clock, it means that there is a positive edge, first positive edge, and this clock is this will affect X directly. So, and J is 1, K is 1, so obviously they are in toggling mode. Okay, correct? Output will be toggled. So, X will become 1. So, what happens is 0 to 1 transition has happened. 0 to 1 transition happens means this flip-flop is also activated because positive edge, right? 0 to 1 transition is a positive edge to the next flip-flop, correct? So obviously the next flip-flop will toggle. Y also will become 1. Okay guys, is this one clear guys? Let me know whether it is okay or not according to the concept. Yes, right? No questions. So when you apply second clock, obviously X will be affected. So this will become 0 because that will be toggled. Now 1 to 0 is a negative edge, it's not a positive edge. So this will not be affected. So 1 will remain as 1. Right? Then you apply the third clock pulse. X will be always affected because X is directly connected to clock, right? So X will be 1. 0 to 1 is a positive edge that you are giving as a clock to this. Are you getting it? So this will be enabled now. So 1 will become 0. Are you getting it? So what is the question? Question is, what is XY after 3 clock pulses? Correct? So option C is right answer. Now I told you something here, right? Positive edge and Q will act as a down counter, right? Now, if you consider here, they didn't mention anything about MSB and LSB. Now, can you tell me which one should be considered as MSB, which one should be considered as LSB, according to the discussion that we had? Either X or Y, right? Suppose if I analyze the same circuit with Y as MSB, X as LSB, what is this? 0, 0, 1, 1, 1, 0. Like, see this? I wrote Y here, right? I'm just writing this Y here, correct? So, 1, 0, then what? Right? Then 0, 1. Obviously, if you analyze, this will be 0, 0. What is this? 3, 2, 1, 0. What is this? Down counter, right? That is what we have discussed here, right? We also positive edge and Q as a down counter. So don't need to worry. Just you remember in the entire digital electronics, you remember this. Negative edge triggering, Q as a clock, will act as a up counter. Obviously, you know how to derive the other things. And you can cross check once whether it is making sense or not when you are in a hurry. Okay, I think I have other questions also, but it's already time up. So if you have any questions, you can ask me. I think next week we will see some problems on synchronous and asynchronous and all those things. Maybe after that week we can see about static timing analysis, and then we can close this mentoring sessions. If you want more, we can discuss. Okay. So if it is helping, then we can have one more session or two more sessions. It's okay, doesn't matter how many sessions. Still, you guys want it, we can continue. Maybe two, three sessions. Like otherwise, maybe next or next we'll stop. Okay. So if you have any, if you don't have any questions, you can leave the session. No problem. I'll wait for 2, 3 minutes, and then I can end the session. Yeah. Hmm. You mean to say F by 3, F by 7, F by 4, I mean F by 8, like, yeah, we cannot achieve it through here, whatever the configuration that we have drawn, but there is another configuration which we can achieve it. We can do that, but this configuration doesn't support as it is. We have to tweak it a bit. Next week we will see. Okay, Avinash, welcome. I'll wait for 2 more minutes. If you don't have any questions, then we can stop. Yeah, welcome. Okay, welcome, Bunty. Sure, Ramesh. Yeah. Hmm. Exactly, correct. Hmm. Obviously, no, because that's where whenever you apply the clock, the change will happen only to the flip-flop where the clock is connected. So that obviously whatever changes very fast is nothing but LSB. Yeah. Yes, Bunty. They're different. We will see a lot of problems in the next week. Okay. Yeah. Today it's all about just to get the flavor of it. Okay. The other things and all will come in the next week. The exceptions and all the things. Uh, okay then. I think no questions, so I can end the session, right?